I'm talking briefly about the land condition project. The aim of our work, first I'll acknowledge it's a collaboration of DPI and DETSI, as well as input from our local NRMs. Brad talked a little bit earlier about land condition, but it's basically the capacity of land to turn rainfall into useful forage. We've got this ABCD framework, and as you slide down in condition, your ability to turn rainfall into useful forage declines. Now, you determine land condition based on soil characteristics, pasture, and woodland features. And our aim in this work is to map land condition across a large part of the Queensland grazing lands. Sorry. Okay, so there's a few parts to this project. The first part is data collection. So we use the LCAT app, which was developed by Rob Hassett, who's currently with DPI. It's an app that sits on your phone. You walk a site, and we've walked thousands of these now. You spend about 10 to 15 minutes on the 1 hectare site, and LCAT provides you with a series of prompts about the soil, the pasture, the weeds, the trees, and a few other variables. You input all that. There's an algorithm that sits behind it, and it provides a series of outputs, which you see there on the right. One of these is an ABCD assessment. We collect data specifically through our science team, but also a lot through our extension networks. There's also data coming in there from some NRM bodies in the region. Once we've got the data, it goes to a land condition model. So this is done by our colleagues at DETSI. So Beck is using a random forest model. Currently, there's about 4,000 sites in that model that she's using. She's looked at over 100 predictor layers. So we're using spatial layers here to predict at the sites where we recorded condition. It's a standard sort of modeling process with cross-validation. There's also a 10% holdout data set. And I won't go into it here because it takes time, but there's a segmentation process that sits behind it. Basically, we're predicting condition in chunks across the landscape. And you can see the results there. That's not the most current one, but that is the one that was presented at the conference. So we're not too bad with our A's and our D's. Things get a little more confused in the middle of the spectrum, the B's and the C's there. And that kappa statistic there is an indicator of how well it fits, and that indicates lower sort of moderate predictive skill at this point in time. So just a few, in terms of the map we produce. So there's an example there of a segment of the Beutel. So left-hand side is an ABCD map. Right-hand side is the same landscape, just looking from the sky. So what we're finding here is there are challenges to this, and the big one is that land condition is multidimensional. It's not just about ground cover. It's not just about your species composition. It's not just about how many weeds you've got. Our current model leans very heavily on ground cover statistics and rainfall history, because those are things that we've got access to. What we're trying to do going forward, and we've had some success with this, is to build layers of particular species that have a big impact on land condition ratings. So we've got a reasonable one for Beutel. We're trying to get something that works with Indian Cooch because we think that'll help a lot. And just to conclude, looking forward, we're also looking at how we present this data once we're satisfied with it. We could produce an ABCD map like you see there. We could have a simplified version of, say, just a deconditioned map. And we're also looking at the delivery channels for this, because there's a lot of places it could go out. It's about where it goes and how we package that.